In this video we are continuing with indeterminate difference. In the previous video we covered the theory work and we said whenever we need to solve an indeterminate difference problem, then we need to try and simplify this expression, and thereafter we need to see what the limit is. If it's 0 over 0 or infinity over infinity, then we should be able to apply L'Hopital's rule. So as per usual, what I like doing is to have this graph drawn, and one easy way of having them drawn is to use an online software, a free software of graphing. So what happens here is that the red graph is then the graph of sec x, and this one is the graph of tan x. So now the question asks us to determine what the limit of sec x minus tan x approaching pi over 2 on the left side. So this is where we are. We are approaching pi over 2 on the left side. So looking at sec x here approaching pi over 2 on the left side, we would see that this goes towards infinity, minus looking at tan x approaching pi over 2 on the left side, we see that also goes towards infinity. So now essentially we have a case whereby we have infinity minus infinity, so meaning that it's an indeterminate difference. So we did say that whenever we need to solve such a problem, we need to first see if we can simplify and then try to have it written as a quotient. So then what we're going to do is we're going to write this down, and then this is the same as 1 over cos x minus, this can be written as sin x over cos x. So if we try and simplify this again, we have lim pi over 2 to the left. We simplify this, we then have cos x 1 minus sin x. So as usual, what I did, I had drawn what the graph of 1 minus sin x is, right? And bear in mind what we're doing is we are approaching pi over 2 from the left side. So if we're looking at this one, as we approach pi over 2 on the left side, this goes towards 0. And we're looking at the graph of cos x, we are approaching pi over 2 on the left side, this also goes towards 0. So then now essentially we have a case whereby we have 0 over 0. And we did say that whenever we have 0 over 0, we are able to apply L'Hopital's rule. And L'Hopital's rule states that this new limit will then be equal to the limit of the derivative. So let's write this down, lim. So the derivative of this will then become cos x minus over minus sin x. So I've applied L'Hopital's rule and determined what the derivative of that is. It's going to be that. This derivative will be this. So then now, if you could draw as well this, or even for argument's sake plug a value here, you would see this simplifies to 0. So that's how we work with indeterminate difference.